So hello guys, welcome to NexTechX. In this video, we are going to master the four most important libraries for data analytics and data science. That is NumPy, Pandas, Matplotlib, and Seaborn. We are going to study NumPy for complete numerical computing, Pandas for data manipulation and analysis, Matplotlib for data visualization, and Seaborn for statistical visualizations. We will start from the basics, work through practical examples. We will learn these things from a data set using a real data set, and then learn everything you need to analyze and visualize data with Python. So let's get started with our tutorial. Hello guys, welcome to the channel. So today we are going to discuss complete NumPy library. Okay, so let's understand what is NumPy? So NumPy stands for numerical Python. Okay. So it is one of the most popular Python libraries used for working with numbers and arrays. Okay. It provides a powerful data structure called an ND array. ND array means n-dimensional array, which allows us to perform mathematical and numerical operations. Okay, quickly and efficiently. In simple words, NumPy is a Python library that helps us to work with large amounts of numerical data faster and with less amount of code. Okay. And second thing is what an array. What is an array? So an array is a collection of elements of the same data type. Remember the same data type is stored together in memory for Python lists. But it is not Python list. Basically, NumPy arrays are designed specifically for numerical computations. Okay, so let's understand this complete NumPy practically. Okay, so for practical purpose, I am using Jupyter Lab. If you don't have Jupyter Lab, you just need to install here Anaconda prompt in your system. Anaconda Navigator. Okay, in my system, it is already installed. Okay, so this Anaconda Navigator you need to install, and after installing, you need to search here in your here Anaconda prompt. Okay, Anaconda prompt. Okay, and then paste the path of your folder. Okay, now let's understand why do we need NumPy. Okay, so for example, you have a list. Okay, you have a list marks. Okay, marks. Let's take some marks here. 85, 90, 78, 88, 99. Okay, so these are my marks. Okay, now now I want to add 5 marks for my each mark. Okay, each marks I need to add 5 marks. Okay, so without using NumPy, you need to use your for loop. Okay, so then first you need to let's create a new list, new marks. Okay, and then using for loop, we need to append this new mark. Okay, if I am not using NumPy. Okay, so for this, let's say I'm using for loop for, let's take a variable for mark. Mark is my variable. I have taken for mark in marks, and what I need to do, I need to append my new marks, this one, by mark plus 5, plus 5. Okay, plus 5. Okay, now if you will print your new marks, print your new marks, if you will print your new marks, you can see 85 to 90, 90 to 95, 78 to 83, 88 to 93, 99 to 104. But, but if you will have some like 1 million marks, 1 million data, what you will do? If you will use for loop for that, your program become very slow, very slow. Okay. So to to basically solve this problem, we will use NumPy. Okay. NumPy's backend is made up of C language. Okay. So that's why it is very faster. Okay. So same thing I will do by NumPy. I will import NumPy as NP. Okay. Import NumPy as NP. And now I will convert this mark, let's say mark 2, I'm taking mark 2. I will convert this to array, np.array. Okay. And I will simply copy this. Okay. I will convert this list to array. Okay. And just what I need to do, print, print mark 2 plus 5. You can see your marks has become 85 to 90, 90 to 95, 83, 78 to 83. So it has added 5 marks to each. Okay. So this is how NumPy works. Less line of code and very, very faster than these for loops and all. Okay. So that is why we use NumPy. Okay. Now let's start with creating arrays, some arrays. Okay. So what is an array? I have already explained. Array is a collection of elements of the same data type, but it is unlike Python lists. It basically NumPy arrays are designed specifically for numerical computations. Okay, so let's create some NumPy arrays. Okay, let's give a markdown here. Creating some arrays. Okay, I will give this as a markdown. Shift plus enter. Now let's create let's create first one dimensional array. How we can create one dimensional array? Let's create, let's say array one is equal to np.array in the parenthesis. For 1D array, you will use one square braces only, 1 comma 2 comma 5 comma 6 comma 6. Okay, this is our 1D array. Okay, 1D array, 1D array. This is our 1D array. Okay. Now, if you will print your array 1, this is our 1D array. This is how something 1D array looks like. Okay. Now, let's create your two-dimensional array. Two-dimensional array. Okay. Let's create array 2 is equal to, again, I will use np.array function. And then in the parenthesis, this time I will use two square braces. First square braces, open and close, and then in the square braces, I will take something like 1, 2, 3, 4, and again comma. Now two items. Let's say 5, 6, 7, 8. Okay, it is your 2D array. 2D array. 2D, sorry, 2D array. Now if I will print my array 2, now you can see this is how something like uh, two-dimensional array looks like. Okay. Now let's create some. I will give a markdown here. Let's create some arrays by inbuilt functions. Inbuilt functions. Okay. Inbuilt functions. Okay. I will give a markdown. Now, now let's create some arrays by inbuilt functions. Let's say I want to create a 2 by 2 array of zeros. Zeros. Only zero it will contain. My array will contain only zeros. Okay. So what I will do, np, I will write np dot zeros. I will store this into a variable array3 is equal to np dot zeros, np dot zeros, and here I will give 2 by 2, 2 by 2. Okay. And then if I will print my array3, array3. Now, this is how zero array looks like. Okay. First inbuilt function by zero array, we have created an array using zero function. Okay. Now, let's say you want to create array of ones. Here in this array, I have only zero number. I want to create an array of only one. Array of ones. Simply, I can create array 4 is equal to np dot ones. Let's say in which dimension? Let's say 2 into 4. 2 into 4, comma 2 into 4. Okay. And print your array 4. Array 4. You can see. You can see. It has two rows and four columns. Two rows and four columns. Okay. Two into four means two rows and four columns. Okay. And p dot ones. Okay. Now let's customize this by taking any other value, not only 0 or 1. I want to fill, suppose, 5. How we can do that? Suppose I will create array 5 is equal to, now what I will give np dot full, np dot full, and suppose I will give dimension here first. Let's say I will give dimension 3 by 3. Okay. And what I need to fill? Need to fill 5. Okay. Just give 5 here and then print array 5. Okay. You can see array of 5 I got by np dot full. This is my dimension 3 by 3, 3 rows and 3 columns, and I have filled all the items by 5. Okay. Now, now how to create an identity matrix? Okay, identity matrix. Simply, you need to give your array 6. I need to store this into array 6 variable and just write np dot use np dot I, and in what dimension? Let's say 4. Okay, it will create 4 into 4 identity into 4 into 4 dimension. It will create an identity matrix for you. Okay, let's create print array 6. Now you can see I got my identity matrix by 4 into 4. 4 rows, 4 columns. Okay, so this is how identity matrix I can create, and then uh, you can use something like np dot arrange, or also np dot arrange, not arrange. Okay, let's say I will give 1 comma 10 comma 3. This 3 means every third value I want to get every third value. Okay, now you can see, I what I said, np dot arrange, give me 1 to 10. 10 it will not consider, 10. I said give me 1 to 10 values in an array, and I want every third value. So after 1 I got 4, after 4 I got 7. Because I have given the end value 10, it will not consider 10 also. Okay, so simply You can check by one thing also, that is your line space, np dot line space. Okay, this means like I want to, let's say I'm giving 0 to 1. 0 to 1, I want my values 0 to 1. And number of points I want to generate, let's say 5. 5 points I want to generate from 0 to 1. So what it will do, it will evenly space, it will create an evenly space between 0 to 1 according to 5. Okay. So if I will print array 8, array 8, okay, not line space, it is namespace. Yeah, you can see. First, it has first, you can see it has generated five values: 0, 1, 2, sorry, 1, 2, 3, 4, 5. Okay. So how it has created an evenly spaced array using five number of total items. First is that it has taken 0, then 0.25, 0.5, then 0.75, 1. All the items are evenly spaced. Okay. And because I have given 5, so it gave me 5 values. Okay. Between 0 to 1. Okay. So this is how some inbuilt functions you can use of NumPy. Now next, let's check. Let's check. Let's get how to check, how to check, how to check array properties. Array properties. Okay, how to check arrays properties. Okay, I have given markdown here. I will give markdown skip plus enter. Okay, how to check property. Okay, now let's create an array first. Let's say array 9. Array 9 is equal to, I am taking, simply I will give np dot array. Okay, in the parenthesis. Let's create a two-dimensional array. Okay, two-dimensional array. And in the first item, I will take suppose 20, 30. The second one, I'm taking, let's say, 70, 80, 90. Okay. Now, first thing you can check, print your array 9 dot shape. What is the shape of your array 9? Okay. 2 by 3. Two rows, three columns. If I will print, suppose I will do this here. I will print simply array 9. Okay. And now if you will check your array dot shape, array 9 dot shape, you have two rows and three columns. Two into three. Two rows and three columns. Okay. This is how you can check your shape. Now you can check your print size of your array. Means how many items, how many total items are elements are there in your array 9 dot size. How many elements in your array? 6. 1, 2, 3, 4, 5, 6. Okay. Next thing you can check, what is the dimension of your array. Okay. I know this is two-dimensional array, but let's see how we can check. Print, print, print array 9 dot endim. Okay. Two-dimensional array. Okay. Two-dimensional array. Now, Now I want to check its data type. Okay. I want to check its data type. Okay. Data type. simply I will write array 9 dot d type, d type. Okay, int 64. Integer is the data type of this array. Okay, now how to change the data types? How to change the data type? Okay, how to change the the data type? How to change the data type? Give a markdown. Okay, now let's say I will create a new array. Array 10 is equal to, let's say, np dot array, np dot array, and I will give, let's say, 10, 20, 30. Okay, and I will give, let's say, d type is equal to np dot flow. This I am giving, it will be in the float data type. Okay, so if you will print here, print array 10, array 10 dot d type. So okay, I will need to give float 32 or float 64. So this is my data type. Okay, float 32. Now I want to change it from int 32. Okay, so simply let's say I will create array int is equal to array dot. I will use s type, ASTYPE, s type, and what I need to change. Sorry, I am changing array 10, right? So I will need to give array 10, and then I need to change it from int 32, from float 32 to int 32. I am changing it. Okay. Now, if you will print your array int dot d type, you will check that. You can check that in 32 I got. Okay. So this is how, using as type, ASTYP, as type, you can change the data type of array. Okay. You can change the data type of array. Okay. Now, next is your how to reshape, and flatten, flatten an array, an array. Okay. How to reshape and flatten an array. I will give a markdown here. Yeah. Now let's create another array. Array 11 is equal to np.array. Again, I will create a two-dimensional array. Let's say 1, 2, 3, and let's say 7, 7, 8, 9. Okay. Now, if you will print array 11, array 11, it is looking like this. Okay. And if you will print your array 11 dot shape, array 11 dot shape, you will get 2 comma 3. 2 into 3 means 2 rows and 3 columns, right? Now I want to reshape this to 3 by 2, means 3 rows and 2 columns. Okay, how we can do that? Now let's say I am creating a new variable. Reshape is equal to, I will use a let's say I will use reshape array dot array 11 dot reshape reshape. In which order I need to reshape? 3 comma 2. So I will just provide this 3 comma 2. And I want to reshape sorry, array 11, and I am using reshape function. Okay, reshape function. Now, if you will print your reshape, print reshaped, now you can check that. It has converted from 2 into 3 by, from 2 by 3 to 3 by 2. Okay, 3 into 2. Three rows and two columns. Okay, so this is how we can reshape an array. Now, you can flatten the array. Flatten means how you can change the dimension of an array. Means from two dimensional to one dimension. Okay, so simply you can write flatten. We can give any variable name you want to store. Flatten. Let's say array 11 dot. You need to use flatten function. Okay, array 11 dot flatten. Okay, print flatten. Okay, now you can see 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. It has converted your two-dimensional array to one-dimensional array. That is what flatten do. Okay, so next is our indexing and slicing. Indexing, 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 and slicing. Okay, I will give a markdown here. So let's create a new array. Array 12 is equal to, again I will create a new array. Again, this time let's say I'm taking one dimensional array. Okay, 10, 30, 50, 70, 90. Okay, now, now let's say it will simply work like Python, how we learned indexing in Python. It will start from your 0, 1, 2, 3, 4. This is 10 is at your index number 0, 30 is your at index number 1, 50 is at index number 2. That is how it will work. Let's say I will print array 12, go to array 12 and give me the zeroth number index element. Okay, now you can check. At zeroth number index, my element is 10. So it has provided 10 simply. And let's say you want to fetch your last element. You don't need to count as 0, 1, 2, 3, 4. You can give 4 also here if you want to fetch 19. But if you want to fetch your last element, you can simply use -1 also. Print array 12. Array 12, give me the -1 index element. You can see 90. It has provided 90. Okay. Now, next part is your slicing. Okay. Next part is your slicing. Let's say I want to print array 12. I want to print from first number index. What is that your first number index? 30. From 30, I want 70. 30 to 70, I need to print. So simply you can count 0, 1, 2, 3, 4. And what I need to print? 30, 50, and 70. So I will take from index number 4 to 0, 1, 2, 3, 4. I will consider 4 also because at 4 index number, it will not consider 90. It will count only till third index number. If I will provide 1 to 4. 1 to 4. Okay. Now, It has given me 30, 50, 70. It will not count your fourth number index. Okay. It will be if you will give 4 here, it will be stopped at 3. It will if you will give 3 here, it will be stopped at 2. Okay. So let's see. Uh, and let's say you want to fetch your starting uh, 4 elements. Simply you need to give this. Don't need to give 0. Okay. Right. Yeah, you can see. Okay, starting 4 values I got 10, 30, 50. Now you want to fetch every second element. Okay, every second element means you are saying that you are saying that give me all give me all give me all elements, but give me every second element. Skip one element at each item. Okay. So simply I will give 2. Now you can check. It has provided 10, 50, 90. It has skipped 30. It has skipped 70. Okay. So this is how slicing works. Okay. Now our next topic is what is NDA. So the main object in NumPy is called an ND array. So the word ND array means n-dimensional array. Here n means any number of dimensions and array means a collection of similar elements. Okay. So let's understand also axis. For 1D array there will be only one axis. Axis is equal to 0. In 2D array, you will have uh, two axes. Array 0 will be your rows and array 1 will be your columns. For example, here we have taken two-dimensional array. Here 2 is your rows and 3 is your columns. 2 rows and 3 columns. 3 columns. Okay. So and for 3D array, there will be three axes. Axis 0 will become your depth, axis 1 will be your rows, and axis 2 will be your column. Okay, so let's understand this clearly now. Now let's suppose taken, I will give a markdown, let's say multi-dimensional array. Give the markdown here. Okay, now let's take uh, array 13. Let's make a variable array 13 and suppose take two-dimensional array in it. np.array. np.array. Now let's create some items 1, 2, 3, let's say, and then I will take, let's say, 4, 5, 6, and then let's say I'm taking uh, 7, 8, 9. Okay. Now if you will print your array 13, it will look like this. Okay. Now, so here axis 0 will be your rows, axis 0 will be your rows, and axis 1 will be your columns. Axis 1 will be your columns. Okay. So if you will print, suppose print np.sum, you if you will add all the numbers at your array on axis 0, let's say x is equal to 0. Okay. Array 30. 12, 15, 18. Okay, add this. 1 plus 4, 5, 5 plus 5, 5 plus 7, 12. 2 plus 5, 7, 7, 8 plus 8, 15. And 3 plus 6, 9, and 9 plus 9, 18. So this is how it has added. Okay, all rows. Okay, now at the down of each column, it has added all the elements. Okay. Similarly, on the axis one, we can add axis one 6, 15, 24. Okay, 1, 2, 1, 2, 3, 3, and 3 plus 3, 6, and then 4, 5, 6, 4, 5, 4 plus 5, 9, and plus 9 plus 6, 15, 7 plus 8, 15, 15 plus 9, 24, 6, 15, 24. So it has added like this, okay, on the axis 1. Now, next thing, let's say how you can do indexing in multi-dimensional arrays, okay. So let's say you want to print array, let's say 1 comma 2. Which value it will fetch? It will go at the index row number 1. What is the index row number 1? This one 4 5 6 index, 4 5 6 index, right? This is the row number 1. This is the row number 0, and this is the row number 1, row number 2. Okay, this is the index of like row index number 1 will be this, and 2 will be your index number of your column. Okay, column at index 2. What will be the column of index 2? 0, 1, 2. At the at the first index number row, give me the second column, means 0, 1, 2. So I am fetching the number 6 element. Okay, 13. Yeah, you can see it has done 6. See, 1 will fetch for row number 1. Which is your row number 1? This one 4 5 6, because 1 2 3 is your row number 0, row index number 0. This is your row index number 1, and this is your row index number 2, 7 8 9. And then it will go for second number column. 4 will be your row column index number 0, 5 will be your column index number 1, and 6 will be your column index number 2 on the first row index. Okay, so it has given me 6. Now, you can do slicing also. For example, if you will give print array 13, let's say 0, 2, and let's say 1 comma. It will basically it will extract first two rows 0 to 2, and last two columns. Okay, last two columns. Okay, first two rows it will fetch for first two rows 0 to 2, and last two columns 1 and 3, means 1 and 3. Okay, or let's see, 2 3 5 6. Okay, so this is what it has fetched. Now same thing, we can check for indexing in 3D arrays. Okay, let's say giving indexing for 3D arrays. 3D arrays. Okay, now let's create a 3D array. Array 14 is array 14 is equal to np.array, np.array in the parenthesis. This time we will give two square braces, and in two square braces you will give your items 1 2 3, and then second item, let's say 4 5 6, and let's say 7 8 7 8 9, and then you will take suppose 10 11 12. Okay, Now, if you will print your array 14, it will look like this. Okay, it will look like this. And if you will print your array 14 dot say, array 14 dot say, you can see 143 means 1 is your depth, 4 is your 1 is your depth, 4 is your rows, 3 is your columns. There are 4 rows and 3 columns. Okay, and 1 depth. Okay, now suppose if you want to create let's say 2 depths, so you will need to give extra square braces. So I will need to give a square braces here. So it will become a 2 depth. One depth will be this, two second depth will be this. Okay, one depth will be ended by this square braces, and then I have my second depth. Okay, now here you can see this is my 1, 2, 3, 4, 5, 6 is at my depth 1, and 7, 8, 9, 10, 11, 12 is at my depth 2. Okay, now you can see this is your depth 2. 2 is your showing total number of depths is 2. There are total two rows in each depth and three columns in each depth. Okay, so this is what it is saying in array 14 dot shape. Okay, now how to access elements in 3D. Let's say I will print ar- print array 14. Let's say I will first give depth. Okay, so I have to give the index number of depth, 0 or 1. There are two depths here, 0 and 1. So let's say I am fetching any value from 0 number of depth. Yeah, that means first number of depth. Okay, 0, and then I am considering first number of row means my second row, 0th index number row, and this is your first index number row in your 0th depth. Okay, and I am fetching my second column row. What I am saying, what I am saying Consider my 0th number of depth means the first number of depth. Index index number 0 of my depth means this is my first depth, and then go for my first index number row. This is my 0th index, and this is my first index number of row. So I will consider this 4, 5, 6, and then go to my second column. Second column means 0, 4 at 0, 5 at 1, 6. So I will get 6. Yeah, you can see. I got 6. Same way you can do slicing also. Let's say I want to get the first row from both depth. What I can say, give me the all depth, will say 0, and all the columns. Array 40. Array 40. Now you can see 1, 2, 3, and 7, 8, 9. What I have given here, give me all the number of columns and consider all the depths, and but first choose the first first index number of row, means zeroth index number 1, 2, 3, and from the second depth consider 7, 8, 9. So that is what I got 1, 2, 3, and 7, 8, 9. Okay. Now let's understand about some data types in NumPy. There are some common data types in NumPy are like mark down something. Uh, some some common common data types in NumPy in NumPy. Okay, I will give a markdown. Shift plus enter. Now I will something right for integer data types. You have you have int 32 and int 64. Okay, and now for float data type you have float 32 and float 64. Okay, next is your for boolean you have bool. Okay, next is your for complex data type complex you have complex 64 and 120 complex 120, and for object, and you have object also for storing something like strings. Okay, strings. I will give a markdown. Okay, now I have already discussed how we can change the data type. Okay, how we can change the data type by as type using as type. ASTYP as type. Okay, I've already discussed this here. Dot as type where I have converted float 32 to int 32. Okay, I have already discussed this. Now let's understand uh, string data type in NumPy. Let's say I will take array 15 is equal to nb.array. It will look like something. It will something look like this. Let's say I have first element as apple. I have second element as banana. I have third element as let's say mango. Okay, so this is how your data type will look like, and sorry, your string data type will look like, and you need to give u10 u10 or something like that means under 10 characters. Okay, under 10 characters you will have the value, you will have your value. Okay, if you will print array 15, it will something look like this. Okay, it is your string array. Okay, similarly for, for complex data type, it will look like something. It will something look like this. Let's say array.16 I will create, and then I will give some imaginary part and real part for complex number. Let's say 1 plus 2j, which is our 1 is your real value and 2j is your imaginary part. Okay, so this is how complex number looks like. Okay, 4j, let's say, and 5 plus 6j. Okay, and d type I will give object. object, object. No, sorry, I will give because it is a complex data type, so I need to give complex 64 or complex 128, right? So I will give like complex 64, suppose. Okay. And I will print array 16, array 16. Okay. So this is how your complex data type will look like. Similarly, object data type, let's say array is equal to array 17 is equal to np dot array, np dot array. I will give square braces, and here you need to give something like you will have mix data type here, mix data type. Let's say I will give some dictionary type data. Okay, dictionary type data. Let's say I will give like this. Suppose A is one, A is our key, and one is our value. And then suppose I will give a list. First, I have given a dictionary. Then let's say I will give a list, and then suppose I will give a string. Hello, hello, hello. I will suppose, and I will give d type. D type is equal to object. Okay, object. Now print array 17. So here this is how it looks like. Object data type. Okay. Next topic is our what is broadcasting. So broadcasting, which something we have discussed at the very beginning of this video where we have started this video. So let's understand again what is broadcasting. Broadcasting is a feature in NumPy that allows arrays of different shapes to perform mathematical operations together without manually changing their size. In simple words, broadcasting automatically stretches the smaller array so that it matches the shape of the larger array, allowing element-wise operations. Important point is NumPy does not actually copy or duplicate the data in memory. It only behaves as if the smaller array has been expanded, making broadcasting both fast and memory efficient. For example, let's understand this. Let's give this as a marker, broadcasting. Now, let's understand this. So, we have already discussed why loops are slower than NumPy, than using NumPy. We have already discussed at the very beginning of this video, right? So, now let's understand without using any loop, let's say array at 18, I will give. Without any using any loop, we can we can basically solve our problems using NumPy. Okay, let's say I will create an array np.array. Let's say I have a list 1, 2, 3, 4, 5. Okay, now I want to I want to multiply this all the elements in this list by 2. Okay, not multiply. I want to square. I want the square of each value. So Simply using NumPy, I can create array multiply by 2. Okay. If we will print your result, you can see. Now you can see it has squared each value. So it got very simple. It is it gets very simple using NumPy. Okay. So if we will not use NumPy, we will have to give a for loop here. And then if I will have millions number of records here, then loop will become very slower. Okay. So that's why we use NumPy. Okay. If we will use for loop, here only there are five number of elements, but when we will have suppose million number of elements, then it will become very slower. Okay, it will become very slower using loop. So that's why we use NumPy. And let's understand more, basically broadcasting in more depth. Let's say I have two arrays. Let's say array 19 is equal to, this is a two-dimensional array. Two-dimensional array this is. Let's say 1, comma 2, comma 3. And let's say 4, comma 5, comma 6. Okay. And let's say I have another array, let's say array 20, and I have np dot array. This time I will take 1D array, 1, 2, 3. Okay, so I have a 2D array and 1D array. Okay, now if I will add result, let's say result 2 is equal to, if I will add 19 or 19 plus array 20. So if you will print your result, if you will print your result, it has given this. Okay, it has, oh sorry, result 2. Now you can see it has added 1, 2, 3 to each number of elements in the two-dimensional array. Okay, so that is what we have discussed here. Okay, it will it allows arrays of different sets to perform mathematical operations together without manually changing their size. So if you will not use NumPy and you will try to add two-dimensional array and one-dimensional array, it will give you an error. But using NumPy, we will not get any error. Okay. So I have added 1D array and 2D array together. Okay. So let's take one another example. Let's say this time I am taking array 21 is equal to np dot array, and I'm taking two-dimensional array. Let's say 10, 20, 30, 30. Okay. Now let's take another 15, 30, 45. Okay. Now let's take 60, 70, 80. Okay. Now, now uh, let's find its normalization. Okay. For normalization, we need to find out the mean. So simply you can use mean is equal to array 21 dot mean. What is the mean of that array 21? Array 21 dot mean, and you will give axis is equal to 0. Okay, axis is equal to 0, and you need to calculate standard deviation also for normalization. So you will take array 21 dot standard deviation, and again you will give x is equal to 0. Okay. Now, if you will print this mean and STD, standard deviation. So this is what your mean and standard deviation. Okay. Now, let's create normalization is equal to, let's say, normalized data is equal to, you need to minus your data. What is the formula? Data your data means here your data is array 21 dot minus mean divided by your standard deviation. Okay, this is what we have calculated, standard deviation and mean. So it will give you normalized data. Okay, so this is what you get as your normalized data. So this is how we can do broadcasting. Okay, so for doing these mathematical calculations and all, you need to use for loop and all, and your program will become very slower. Okay, so you can use these things. Okay, for doing some mathematical operations by NumPy. Okay, so that is why NumPy is built for doing these calculations, or like for, like, let's say you need to calculate mean, you will need to basically write a logic. Okay, if you will not use NumPy, here you can see within a single line of code you got your mean, you got your standard deviation. Okay, this is why we use NumPy. Okay, so there are some built-in mathematical functions we can use. Let's give a markdown here. Built in some some built in mathematical functions in NumPy. Okay, now let's create a array. Array 22 is equal to np dot array. Np dot array. Let's say 20, 30, 40, 50, 60. This is your array. Okay, so I have given an array. I have taken an array. So basically, many you have many mathematical inbuilt mathematical functions you can use. Let's say first is your np.mean for calculating the mean. Okay, np.mean. You need to give your array 22. Here you can see you got 40. 40 is your mean here. Okay. Now let's say you need to calculate standard deviation for your array. Standard deviation. You need to give std. We have already seen this. Now let's say you need to calculate your variance of your array. You need to give var to calculate your variance. Var. Okay. So this is what you got your variance. You want to you want the minimum value of an array. You want the minimum. So you need the minimum value of your array. Min. Simply you will use min. 20 is the minimum value in it. Okay. Simply you can use max also. Max value in your array. Here you can see 60. And let's say you want to sum, you want the sum of all elements in your array. You can simply write np dot, sorry, just copy paste. Now sum of your array 22. 200 is the sum of your array. Okay. Now product, same you can use product also. Prod. Okay. You need to provide array 22. Okay. So this is what your product. Simply you can use median also. You can calculate your median also for your array. Here you got median also 40, same as me. Okay, percentile you can check. You can check percentile. But you need to give percentile uh, for how much percentile? Let's say I am giving 30th percentile for 30th percentile. So it has given me 32. Okay, it has given me 32. Now next is your you want the index of your minimum value. I think it is the first one. I want the index of my minimum value. You can simply write arg mix arg mean, sorry, arg mean. Okay, zero. Zeroth number of index, you have your minimum value. Okay, simply you can check for your index max also. Arg max. Arg max. Okay. Fourth number of index, you have your largest value. Okay. So these are some inbuilt functions. You can check all. You can check many. There are many functions and inbuilt functions for NumPy. You can check that also. Okay. So you can check that and you can apply this like this. Okay. Whatever function you will get after searching, you can check that also. Okay. So that's all in this video. Thank you. So hello guys. We are going to start our Pandas tutorial today. We are going to master Pandas library, which is very essential for data analytics and data science in this tutorial. So this tutorial will be divided into some modules. So these are some modules here. What is Pandas? Four data structures in Pandas: loading dataset, EDA, data selection and filtering, query, data cleaning and pre-processing, data transformation, reshaping the data, aggregation and grouping, merge like SQL. These things we are going to learn step by step. Okay. So let's start with our tutorial. So first thing is our Pandas introduction. So what is Pandas? Pandas is one of the most popular Python libraries used for working with data. So it helps us in these things like read data from different files, organize data in tables, cleaning the messy data, which you will get, analyze the data, perform calculations, find insights from the data. Okay. So basically, in simple words, Pandas is a library that makes data analysis easy and fast. Okay, so basically, it works mainly with tabular data, which means data arranged in rows and columns like an Excel sheet. Okay, so why do we need Pandas? So suppose you have a CSV file containing 5 lakh customer records. That is a huge data set, right? 5 lakh customer records. So without pandas, reading data will be difficult. Filtering records will take a lot of coding. Okay, calculating average or total is very will be very time consuming, right? But with pandas, reading data is very easy. Okay, filtering records can be done in just in few minutes, a few lines of code. Okay, calculating average or totals takes only one or two lines of code. Okay, that is the power of pandas library. Okay, that's why we data analysts or data scientists prefer pandas library. Okay, now there are two data structures, which mainly two data structures pandas provide: series and data frame. Okay, let's understand these two things. First is series. A series is one dimensional labeled array. So it is similar to a single column in Excel, single column name or age, single column. Okay, don't count the index. Okay, it will be it will be basically similar to a single column in Excel. Okay, like this: name, Amit, Rahul, Priyasne. Okay, and second one is your data frame. So a data frame is a two-dimensional table. It will contain rows and columns also, just like Excel. So it will have, you can see multiple columns, two-dimensional data, table with rows and columns, multiple columns, okay, like Excel sheet, okay. So that is the difference between series and data frame. Now let's see how we can create series and data frame practically, okay. If Pandas is not installed in your system, so you can download like this. Just type your CMD, open your command prompt, okay, and just write pip install pandas, okay, pandas, okay. In my system, it is already installed, so it will show me, yeah, requirement already satisfied, okay. So because in my system it is already downloaded. So if in your system it is not downloaded, so you can use this command pip install pandas, okay. So now let's see how we can create data structure of pandas, which is our series and data frame. Okay, so I will give a markdown here. Uh, creating creating data structures. Okay, in pandas. Okay, I will give a markdown here. Shift plus enter. Now, first one I will create series 1D, which is our 1D labeled array. Okay, first I will create series. So I will give a markdown again. Series. Okay. Shift plus enter. Now, first you need to import your pandas library. Import pandas alias PD. I have imported pandas. Now I can use my pandas library because I have imported pandas. Okay. Then you can create something like series is equal to, it is my variable in which I will store my series data structure. PD dot, you need to write PD dot series, you need to use series, okay. PD dot series, so I will use some s is equal to PD dot series, suppose. Now you can create something like list, okay. 10, 20, 30, 40, something like this, okay. Now if you will print your variable, that is as, yeah, you can see. So this is how it is looking like. This is a single column, this is a single column, and this is your index, okay. That is what we studied. This is how series data frame looks like, okay. Now let's say data frame, how we can create a data frame. Data frame, that is our 2D label table, 2D label table, okay, in which we will have multiple columns and rows. Sorry, now shift plus enter, okay. Now how we can create a data frame. So suppose I am creating a variable data is equal to. Now we can create this like a dictionary, okay. Let's say I will give some names. I suppose I am giving a column name, and I will provide some names like let's say Rishi, let's say Rohan, let's say Rahul. This is my one column. Now, now I want another column in my data frame. That is, let's say age, age. So I have three names, so I will provide three age also. That is, let's say 30, 40, 50. Okay. Now, let's say I want to create one more. let's say I want to create one more column. Let's say salary. Okay, again I will give, let's say 25,000. Sorry, 25,000, 50,000. Let's say 75,000. Let's say. Okay, so these are the three columns I have created. Now, now to I have to basically transfer this into a data frame. Okay, so how we can create? Let's say I am creating a variable df. Df is equal to, I will have to write df is equal to, we will use pd dot, I want to create a data frame. So I will write data frame, use tab data frame. Now, which which one is your data, and what we need to transform into data frame? That is data, because these things I am storing into my data variable. So I need to pass here my data variable. Okay. Now, if I want to see this, my data frame. Okay. Now, here you can see you have this is your index 0, 1, 2, and these are your three columns. Okay, three columns. Here you can see this is age is 30, salary is 25,000. Rohan's age is 40, his salary is 50,000. So that is the difference between data frame and series. Okay, now we are going to see how we can load the data set from like Excel, CSV, database, JSON. Okay, so let's see how we can do it. How to load the data set. So it is very simple in Pandas. Okay, to load the data set. Let's say I have a file. Okay, I have this data set. This is a supermart data set. Okay, in which I have order ID, customer, category, subcategory, city, order date, region, sales, discount, profit, state. Okay, these things I have in this supermart data. Okay, so I suppose I want to analyze this. Okay, and this is very, suppose this is very large data set. You can see around 10,000 records are there in data set. So I want to basically analyze this. So for analyzing, I I will have to basically load this data set here. Okay, I will have to load this data set here. Okay, so I have put this data set in the same folder in which I have opened this here in Jupyter Lab. So it is very simple. Okay, let's say I'm creating a variable. Let's say first I will give a markdown here from CSV file. CSV file. Okay, from CSV file. Okay, so this is my CSV file. Okay, so I want to load this. Simply you just give a variable in which you want to store your complete data set. Let's say I want to store in data set variable. So data set is equal to, you need to read pd.read slash CSV. Your file type is CSV, right? Here you can say supermart.csv. So your file type is CSV. So you need to write slash CSV, and here just click copy path and paste it here. Control plus P. Okay. Now let's say you want to check your data is loaded or not. Just check data.head by data.head. What it will do, it will basically give your starting five records. Okay. But suppose you don't want to see your starting five records. You want to see your starting two records. Just put here two, shift plus enter. Sorry, dataset.head. Okay. Yeah. You can see here. Your data set is loaded, and here because I have given two, So this is my starting two rows. Okay. So similarly, I can load the data. Suppose your file type is Excel. Okay. So let's say I'm giving a markdown here. Excel, Excel. Give a markdown, Excel. Similarly, here you can just what you can do, just paste it here. Just you need to change from CSV to Excel. Excel. Okay. But when I will click Shift plus Enter, it will give me an error because my file type is CSV and I'm writing here Excel. So I'm just commenting this. Okay, so this is how you can load your Excel file also. Excel file also. Okay. So similarly, you want to load your JSON file. I will give a markdown JSON. Similarly, what you can do, just you need to paste your JSON instead of CSV or Excel. If your file type is JSON, just paste it here JSON. So again, my file type is not JSON, so it will give me an error. So I'm just commenting this. Okay. So this is how you can load your CSV, Excel, and JSON file. Okay. Okay. Now, how you can load your data set from SQL databases? SQL databases. Okay. I will give a markdown here. Its syntax will be quite different. Okay. Syntax for this will be quite different. First, what you will need to do, you will need to basically import your, suppose in your SQLite 3, your databases, or you want to store that, you want to load that. Okay. So you need to first import your database. Then let's say you will need to give a variable in which you want to store the data set. Now, what you will do, suppose I have the data set in SQLite, so you will write here SQLite 3 dot connect. You will write connect, and whatever your database name will be. Okay, let's say name dot SQLite. Okay, name dot SQL, whatever the name of your database, we will give name dot SQLite, and then you will transfer this to a data frame. Okay, let's say pd dot read SQL, and you will something like you will give something like select all from from. Let's say your database is about school or college. So something like you want to store a table. You want to load a table. So let's say you have a table students. Okay. So just you need to give a select all from students because your table name is student in the database. Okay. And you will give your variable name, that is our connection. Okay. So this is how you can load your data set from SQLite. Okay. Basically from SQL databases. Okay. The next topic is exploratory data analysis. Okay. EDA. So what is EDA? EDA stands for exploratory data analysis. So it is the process of understanding a data before applying machine learning. So think of EDA as a getting to know your data. Suppose you have a data set, you have loaded a data set, and you don't know anything about your data set. So you want a basic idea about your data set. Okay, so for this we use EDA. Okay, so before making predictions, we answer questions like how many rows are there, how many columns will be there, are there missing values, duplicate values, average salary, highest sales, distribution, outliers. Okay, so basically, why is ED important? So without understanding the data, your model may give poor results, right? So EDA helps us to understand the data, finding errors, detecting missing values, removing duplicates, find patterns, detect outliers, select important features. So in these things, EDA helps us. Okay. So for EDA purpose, I will use this dataset, okay, which I have loaded in dataset variable. I will use this dataset for EDA, okay. So I will give a markdown here, EDA. I will give a markdown, shift plus enter. Okay, I will use dataset variable in which I have loaded the dataset. So there are few things you can use for your EDA using Pandas, okay. So if you can see here, dataset dot, if you will give dataset dot head, it will provide you starting 5 records of your. I will again, okay. Now you can see from dot head, you will get your starting 5 records. Okay. Now similarly, if you will write here, use dot tail, dataset dot tail. I'm using dataset here because I have loaded my dataset in dataset variable. Okay, so dataset dot tail, it will give you last 5 rows. Okay, you can see from last 5 records you have it has given. Okay, using dot tail. Okay, now you can check by dot info also. Dot info. Okay, dot info will provide you the column info types or non-nulls. Okay, so order id, order id is your non-null, customer name is your non-null, and your data type. What is the data type of order id? Object. Sales data type is integer 64, discount data type is float, state also object. Okay, so these are uh, these are objects are basically strings. Okay, and int and float will be your numbers. Okay, so you can see by info your you can check your data type by info also. Okay, so you can check by data let's say data set dot describe. Describe is also a function. You will basically give, you will get all stats for numeric columns. Okay, so all the numeric columns you have, sales and sales, discount, profit is your numeric column. So you got your stats for this. What is the count of these things? What is the mean of these columns? Mean of column sale is this, mean of discount column is this, profits mean is this, standard deviation is this, minimum value of in the sales, discount and profit, 25% of this, 55%, 50% of this, 75% this, of this, or max. What is the maximum value of your in your column sales, discount, profit? So these things we can get from dot describe function. Okay. Next thing you can use, let's say you want to check what are the different columns you have, all the columns you have, you want to check columns. Okay. I will not need to give you a parenthesis. So here you can see these are the list of columns I have: order ID, customer name, category, subcategory, city, order date, region. Okay, these are the columns I have. Okay, so you can check this by dot columns. Now you want to, let's say, check how many rows or how many total number of rows and columns in your data set. You can simply check dataset dot shape. Here you can see you have 11 columns and 9,994 rows in your data set. Okay, so this is how you can check this by dot shape. So these are the things. Let's say you want to check how many null values in your data set. You can simply write data set dot. You can check is null, give parenthesis and just give dot sum. It will give you how many null values are there. So here you can see in all the columns I have, there is no null value. All have zero null value. Means there is there is no missing value or there is no null value in my data set. Okay. So this is how we can do the EDA using Pandas. So that is not all about EDA. Okay. It is done by it are the things, these are the things basically which can be done by Pandas. But when you will do EDA, you will need to plot graphs also. So graphs part I will cover when we will cover Matplotlib and Seaborn. At that time, we will cover how to check by how to do exploratory data analysis using by plotting graph using Matplotlib and Seaborn. At that time, we will see that. But using Pandas, this is how you can do EDA. Okay, so you got to know about your data set. So now you have a basic idea about your data set because of EDA. So this is how we can perform EDA. Okay, now next is our data selection and filtering. So I will give a markdown here, data selection and filtering. Okay, I will give a markdown here. Shift plus enter. Now you can use first we will see data selection. You can use data selection for data selection dot log and dot ilog. For example, I have the variable data set in which I have stored the data sets. Suppose I will give suppose data set dot log. Let's say I want to see the first row dot log. I will keep 6%. This is your first row. All the values of first row. Order ID is this. Customer name is Harris. Category is your oil and masala. Okay. So this is your first row. So basically, data selection is very necessary when you will analyze the data set to basically select right rows and right columns. Okay. So let's say I will go for dataset.log. Now, let's say I want to see this is my dataset.add starting 5 records. So let's say I want to see the customer name Sudha's city. I want to see. So here you can see 0, 1, 2, 3, 4. Fourth number is your city. Okay. I want to see the city of Sudha and customer name is your Sudha. Okay. So if you will see, if you will give you want your first row, right? You want to check your first row and you want to check your city. What is the city of Sudha? What is sorry. Yeah. What is the city of Sudha? Okay. So I will give city. Here you can see. So yeah, here you can see Krishnagiri. Krishnagiri is the city of Sudha. Okay. So here you can see Sudha's city is Krishnagiri. So here, this is how you can use dot log. And let's say you want some multiple columns. Okay. Let's say I want some columns like suppose let's say I want customer name. I don't want to use all my data set. Okay. Let's say I want only customer name and some like I want to check profit. I want to check profit and I want to check discount. Okay. So I don't want to see the whole data. I want only this column. So simply pass this. Log has only one dimension. So first we will need to give rows. How many rows we want? Suppose I want all the rows. So for all the rows, to get all the rows, you will use this and then comma and then you will give a separate square braces for your columns. Okay. Now here you can see you got your all rows and your only three columns is there. Okay, only three columns. So this is how we can use dot log. And let's say I want first three rows. So uh, my variable name is dataset dot log. I want first three rows. Okay, so what I will do, I will give 0 to 2. 0 to 2. Okay. Now here you can see first three rows I get. I got my first three rows. Okay. So this is how dot log can we can use for data selection. Similarly, we can use dot ilog, but dot ilog will use only integer positions. Okay. It will not take like customer name, discount, or profit like this. Okay. It will take only integer position. For example, if I will give dot ilog 0 0, it will provide the same output as log. Here you can see I got the same output by log 0 and dot ilog 0. Okay. So, but let's say, I want dot ilog. Now, I want Sudha's city again. I want to know the city of Sudha again. So, how we can do using ilog? For ilog, we will use. So, I want the first row, right? First row. Sudha is at my first row, and then I want only city. I want only city. So what is the index of city? 0, 1, 2, 3, 4. So I will give 4, 4. Now here you can see Krishnagiri. Okay, same output. But what is the difference between log and ilog? Here I have given 1 comma city. 1 comma city. But here I have given the position. Of, basically, you can say index. Index I have given 4. So I got the same value, Krishnagiri. So that is the difference between log and ilog. Okay. Similarly, you can see like suppose data set dot ilog second row first column Hussain. So what is that second row first column 0 1. So here you can see what is at my first index number of sorry, what is the index number of my customer name? 0 1 1. So what is at my second row? That is Hussein. At index number 1, that is my customer name, and on the second index, second row, I have Hussein. So I got Hussein. So this is how we can apply dot ilog. And suppose I want to fetch multiple columns. So let's say data set dot ilog. Let's say I want to fetch first row, only first row, but I want multiple columns. So I will not give here names of multiple columns like customer name, discount, profit. Instead of this, we will use the index number of those. Like let's say I want the first index number column, fifth index number column, seventh index number column. Okay. So here you can see I got my first row. I got my first row and I got the value for my first index number one column, that is customer name, fifth index number column, that is order date, and seventh index number column, that is sales. So I got this. If you want all the records, not only the first record, don't use zero, use this. You will get your all records now. Okay, so this is how we can use dot log and dot ilog to select the data. Similarly, like for fast access, we can use dot at and dot I8. I8 we can use. So like this dataset dot at, let's say I want to get first row, first row of, let's say first row of customer name I want to get. So you can use dot at like this uh, space I have to remove. Now here you can see Harris. So what is that your first row? First row is this, and what is that your customer name? Customer name first row Harris. So it has provided me Harris. Okay. So that is how dot at work. Here you can see we are providing the name, not integer position. For for dot I8, similarly dot I8, you will need to give your integer position instead of your customer name, instead of your name. Okay, so here you can see like this is my I think first index. Yeah, customer name, order ID at 0, customer name is 1. So here you can see I will give 1. It will give me the same output. Here you can see at index number one, that is my customer name. When we will use dot at, I will use the name, and when we will use dot I8, we will use the index position number. Similar to that, log and dot ilog. Okay, so this is how we can select the data using dot log and dot ilog. Okay, so you can store these things into a new variable also. Okay, suppose you want to store data 2 is equal to, you will store this in data 2, and when you will print your data 2, it will provide you this. Okay, so that is how we can do. And then you can basically analyze your data 2, in which you have stored this separate data, not all the data set. Okay, so this is how you can analyze these things. Okay, you can work with pandas like this. Okay, now let's say I will use filtering. Now I will explain filtering. I will give a markdown here. Now let's say I want to filter something. Let's say first I will simply give a dataset dot head so that I can see my data here, starting 5 records of my dataset. Now let's say I want to see all those records that is greater than, let's say 400. Let's say 400. Okay. So how you can do that? You can simply go for your dataset. What you are selecting? You are selecting from dataset. Again, you will go for your dataset. Now, what is the condition on which column you want the condition? I want the condition on profit. So I will copy this. I will paste this. Now, what is the condition you want? I want all the records. I want all the records of data set in which I have the profit that is greater than 400. So I will simply write 400. Okay. Now here you can see. Now you got your 3937 records, but initially you you had your 9,994 records. Now you got 3,937 records. That is all the records which whose profit is greater than 400. Now here you can see any value will not see which will be less than 400. Okay, so that is how we can use filtering. Okay, you can use multiple conditions as well. Let's say now I want data set. Again, I will go for data set, my data set. Now you can use multiple conditions. Okay. Now let's say I want conditions like profit. On profit, I'm applying again the condition. Let's say I'm saying that profit should be greater than, let's say this I am giving 1,000. 1,000. Let's say I will give 700. 700. I'm saying that profit should be my greater than 700. Give me those data, those records only in which I have the profit that is greater than 700, but the city should be Chennai. But the city should be Chennai. So I'm applying the one more condition. So I will use and. And because both of my conditions should be true, both of my conditions should be true. So I will use and operator here, and I will again go for my data set. What is the next condition I want to apply? I want to apply the next condition on city. So I will provide here city. City. City should be my Chennai. City should be my Chennai. I will simply copy my Chennai city. So what I'm saying? I'm saying only give me those records, only give me those records whose profit is 700 plus date. City should be Chennai only, only Chennai. So this is the condition I am providing here. Okay. So you will use a separate parenthesis for both conditions. I'm I'm applying here also. Okay. Now shift plus enter. Now you can see you got this much uh, data set. Okay, this much records. Okay, now here you can see my profit will be greater than 700. You will not able to see here less than 700 in profit column. And here you can see one thing. City is only Chennai here. You can see only Chennai because we have applied that condition here. So this is how you get to analyze by using in pandas. Okay, so this is how we can do analyze. We can perform operations on our data set. Okay. So these things you will do. Okay. With pandas when you will analyze the data set. Okay. So this is how you can use filtering. Okay. You can use query also. Querying. You can use querying also. Querying also. Okay. Querying. I will give a markdown here. Querying. For example, let's say I want to use dataset dot query and same condition, let's say I will apply here. Same condition I will apply here. Okay. I will say I will say what is your first call and on which you will apply the condition. Let's say profit. Profit. Okay. Profit should be profit should be 700, greater than 700, and and city 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 will be equal to Chennai. Okay, I am applying the same condition, but using dot query. Dot query I am using. Okay, use this single the single tip. Okay. Now what I'm saying the same condition. I'm giving the same condition, but using dot query method. I'm saying profit should be 700 and city will be my Chennai only. Okay. If you will run this, here you can see you got the same output. You got the same output here. Okay. From this line of code also you got the same output, and from this line of code you got your same output. Okay, so you can use both. Okay, so this is how you can use dot query. Next is our data cleaning and pre-processing. So real world data which you will get will never be perfect. Okay, it will usually contain these things. It will contain missing values, it will contain duplicate records, it will contain wrong formats. Like here you can see 25 is 20, 35 30.5 is 30, extra spaces you can get. Okay, here you can see you can get incorrect values. Okay, so basically, cleaning the data is data cleaning, and preparing the clean data for analysis is called data pre-processing. Okay, so data cleaning basically makes data accurate, usable, makes data usable, and both are essential before analysis or machine learning. Let's see how we can perform data cleaning and pre-processing practically. Okay, for data cleaning and pre-processing, we will use this same data, but I have done some changes in this. Okay, so that we can use this data set for data cleaning and pre-processing purpose. For example, I have introduced some missing values. I have deleted some records. I have uh, given some duplicate records. So let's see how we can perform data cleaning and pre-processing on this data set. Okay, so I am giving a markdown here. Data cleaning, cleaning and pre-processing. Okay, I will give a markdown. I will give shift plus enter. Now I will first load my data set. Let's say I am storing this into data2 is equal to, I will use pd.read slash csv because this is my csv file. I will give the path here, right click, copy path. I will paste it here. I will check my data is loaded or not. Okay. Now here you can see my data gets loaded. Okay. I will check, is there any null value in my data set or not? So how we can check? I will go for my data2 dot is null dot sum. It will provide a sum for all the columns. Yeah, you can see it is saying in discount column there are five records are missing. Okay, in profit column there are six missing values. Okay, this is what it is saying. Okay, so what are the operations we can perform? Okay, for our to handling missing values. Simply, suppose you want to drop all missing values rows. Okay, simply you can do data is null, data2 dot is null is sorry, data2 dot drop na. If you will provide this, then it will drop all the missing values from your data set. All the missing values from the data set. Suppose you want suppose you have many missing values. Suppose there are around 10,000 records and one column has around 5,000 missing values. So there's no meaning of that column. So if you want to drop that particular column, so simply you can write data dot drop na axis is equal to 1. Axis is equal to 1. When you will provide axis is equal to 1, it will not simply delete that particular row which have missing values, but it will delete the whole column which has a missing value. Okay. So this is how, okay, here data 2 I have. So I will do this. Okay. So here you can see you will not able to see discount or profit here because it has deleted the whole column, because in the discount column there was five records were missing. In profit column there was six records were missing, so it has deleted that particular rows because of this line of code where I am saying x is equal to 1, delete the column which is containing missing values. Okay. There are multiple ways to handle missing values. Suppose you want to fill any missing value with a particular value. Suppose you have a missing values in discount and profit. You want to fill those missing value with zero. Okay, simply you will write this line of code, data dot fill na zero. What it will do? It will insert zero to all those values which were missing. Okay. Again, I'm giving data. It is data 2. Okay. So this is how it works. Here you can see it was a missing value. It was a missing value. So it has given zero. Okay. It has inserted zero here. Okay. Similarly, suppose you have a profit column. Okay. So for profit column, you can insert or you can basically insert the missing value by its mean. Okay, what is the mean value of your profit column? What is the mean value of profit column? I want to fill but that particular value in our missing value. So here how we can use that? I want to simply fill the missing value by mean of the profit column. So I will use simply data to I am filling profit column, right? So I will write profit dot fill na from what we are filling. We are filling with its mean value. So now I will give data to again I will go for profit. I'm saying I'm saying that fill this by its mean value. Its mean value. Okay. Here you can see. It will filled by its mean value. Okay. So here you can see when I have inserted zero for all missing values, it was showing zero here, right, for the fourth index number. Now you can see at what is that fourth number index? 374 means the mean value of the profit column is around 374.80 something. So it has filled with mean value. So that is how we can fill the missing value. We can use forward fill also. I'm saying fill all the missing value by forward fill. Okay, forward fill. Here you can see on the fourth record it was a missing value. It has filled with its previous value 89.60. Okay, so it it got its previous value 89.60 because on the third row it has 89.60, it got 89.60. Similarly, I can use backward fill also. Data 2 dot backward fill b fill we will use. Now you can see Now you can see it has changed. It is changed to 322 because on the fifth index number there will be value of profit column is 322. Then so it is filled by 322. This is how we can fill missing values. Now next thing is our detecting duplicate values. So how we can detect is there any duplicate value in my data set or not? Data 2 dot duplicated. Here you can see it is saying that on the 9994 and 9995 row number, there are some there are some duplicate values. Okay, there are some duplicate values. It is saying so. So there is no meaning of duplicate values. Okay, it will not gonna help you in analysis. Duplicate value, you will always simply delete your duplicate value. Okay, so simply you can how you can drop your duplicate values. Simply you will write data two because in this variable I have the data set data two dot drop duplicates drop duplicates. Okay, okay. If you will again run this if you will again run this okay, so here in place is equal to you will have to write in place is equal to true. Okay, in place is equal to true. Now if you will check this you will check this because it was providing a copy not a view. Okay, now if you will check here you can see you are getting false here because now there is no duplicate values in your data set by because I have given in place is equal to true. Okay, now next thing is let's say I'm checking my data2.info. I want to check the data type. Here you can see I have the data type of sales integer 64. Rest object data type is your string data type basically. Integer data type, float data type I have. Okay, so let's say I want to change the data type of profit by float to int. How we can do that? In NumPy tutorial I have already discussed, but I am again uh, explaining it. I will go for my variable data 2. I want to change the data type of which one? Let's say I want to change the data type of discount. I will go for my discount equals to data 2 data 2. Again I will go for my same column. What I am doing here, I am changing my data type of discount to from float 64 to int 64. What I will do, I will give as type what I provide int 64 int 64. Okay, int. Okay, so it is not able to convert this. So let's say I want to convert sales sales from int to float. Okay, now if you will see data2.info, here you can see first sales had the integer 64 data type. Now sales has the float 64 data type. Sales has float 64 data type. Okay, so that is how we can change the data type. Okay, we can use PD to date time also. Okay, you can use object also for changing the data type. Okay, so this is how you we can use as type for changing the data type. For date time, we will use pd dot to slash date time. Okay, so this is how we can change the data type. Okay, let's say you want to change a specific thing. Okay, change a specific value. Okay, so let's say you want to change something like you want to change Tamil Nadu to Tamil only. Okay, you don't want to write Tamil. You want to write only Tamil. Sorry, instead of Nadu, you want Tamil. So this is how something you can do that. So I will go for my data too. Now I will go for my column, which is my column. That is our state state column, right? I'm just giving an example how you can change your data particular value of your data. I will use replace. From what we are replacing? I am replacing Tamil Nadu, Tamil Nadu, Tamil Nadu to I am replacing by Tamil only. Okay, Tamil. Okay, so I will use square braces here. Okay, now you can see your state column has replaced Tamil Nadu from Tamil only. Okay, so this is how you can use dot replace method. And let's say next thing is our let's say data transformation. Our next topic is our data transformation. Data transformation. Now let's say you want to sort your values in ascending order. For ascending order for let's say profit. Okay, profit. I will use ascending order for that. So I will simply write data2 dot sort slash values, and I will provide my column, which is my column profit. I will simply copy this. I will provide my column. I am saying arrange my data according to ascending order on the basis of profits ascending order. Okay, so this is how you can see it has provided me this ascending order. Okay, in the ascending order. Similarly, if you want in descending order, simply you need to what you need to give uh, you will simply give here ascending is equal to false because default value is your ascending. So you will give ascending is equal to false. It will provide you in descending order. Now you can see it has arranged your data in your descending order. Okay, you can do that for multiple columns also. Data two dot sort values, and you will provide here your multiple columns. Let's say one is your profit, sorry, profit, and second column is your let's say sales. Second column is your sales. Okay, and you want ascending is equal to false means you want this in descending order. Okay, you can do this. Now you can see it will arrange my data set into descending order from sales and using sales and profit both. Okay. So this is how we can use sorting. Okay. And one few things we can do more. Let's say I want to rename any rename any column's name. Okay, how you can do that? You can simply go for your data two, because I have stored the data set in data two. Rename columns is equal to your let's say I want to change customer name to only customer. I will give customer name, and I want to change this with my new name, that is our customer only, customer. Okay, and I will write here, I will use a square braces. I will use a square brace, and I will write in place is equal to true. In place is equal to true. Okay, there is no customer name, it is only customer. Okay, so this is how we can do that. So next is our, let's say, changing the column order. Okay, so next thing is, let's say you want to change all the columns name. You will simply write columns is equal to, and you will provide your new name here, new names here. All the new names provide in this order. Let's say order, let's say CUST only, customer, not customer name, not customer, only CUST. So this is how you can provide all your columns, new columns name here. Okay, so it will replace that with your new name. Okay, so next is your, let's say you want to change the column order. Okay, just paste your new order of columns name. Okay, simply you will go for data 2, and you will again provide your data 2, and here here I have, suppose, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. So you will provide all 11 columns in whatever order you want. Okay, so this is how you can change the order of your columns also. Okay, so is our aggregation and grouping. Okay, so aggregation, first understand aggregation. Basically, aggregation and grouping helps us to summarize data and understanding it better. So first understand aggregation. So aggregation means performing calculations on the entire data to get a single result. Single result. Common aggregation functions are sum means total, mean means average, maximum value, minimum value, and your total count. Okay. So for example, so find total average, maximum, and minimum of the salary column. Okay. So this is your data, and this is what you get from aggregation. Your sum, average, maximum, minimum, count. Okay. Count is your total number of records. Okay. So this is what are the things which we can do by aggregation. Next thing is your grouping. Grouping means dividing the data into groups based on one or more columns and then applying aggregation of each group. Okay, so this is what grouping is. So let's see how we can perform aggregation and grouping. Okay, so I have created a data frame here in which I have employee ID, employee name, department, gender, city, salary, and his experience in years. Okay, so I have created a data frame here. Okay, so this is how my data frame data set is looking like. Okay, so I have created a data frame here and I have stored this in data 3 and my data frame is EF2. Okay. So now let's understand how we can use dot group by function. Okay. For example, let's say I want to group this by department and then I want to calculate the average salary for each group. Okay. So how we can do that? Let's say I will go for my df2 dot. I will use my group by function. Group by. I want to group by department. Okay. Department, and I will give salary here. I want the mean of the salary. So I will give salary here and I will give dot mean. Okay. Now you can see it is saying finance average salary is 57,500, HRs is 52,000, IT is 70,666, and sales average salary is 48,500. That is what it is saying. Okay. So some common aggregations functions are like you can calculate mean like this. Mean, you can calculate sum like this. You got the sum. Okay. And you can count, you can check this by count as well. You can apply count function also. Count finance 2, HR 3, IT 3, sales 2. So there are two person from finance, three from HR, three from IT, and two from sales. Similarly, I can calculate, I can check my mean and max also. So here you can see from finance, highest salary is this, HR is this. Sorry, minimum salary is 55,000. HR's minimum salary is 48,000, 65,000, 45,000. Similarly, I can check this by max also. Max. Now you can see max from finance, max salary is 60,000, HR 58,000, IT 75,000, sales 52,000. Okay. So if you want to group multiple columns, this is how you can do that. df2 dot group by group by group by provide your columns name. What are the columns name you want? Let's say you want, what are the columns I have? Employee name, department, gender, city. Let's say I want to group department and salary, and then I want to calculate the average salary from each group. Okay, I will give first your all columns you want in the square braces. Let's say I want another column that is, let's say, city. City. I will paste it here. And what I want salaries mean. Salary mean. Dot mean. Now you can see you got your multiple columns grouped by your salaries mean. Okay. So that is how we can use group by function and this aggregation and some aggregation function. These are some common aggregation functions. Okay, you can use. Okay, mean, sum, count, mean, max. Okay, so these are the common aggregation functions you can use. Now, Now let's see how we can merge the data. So for that, I will create two different data frames. Okay. So first data frame, I will give a markdown here. Merge like SQL. Okay. Let's say first data frame I will create. Let's say I will store my data in this employees. I will use data frame, and I will provide this some details here. Let's say employee ID, employee ID. Let's say 123. Next detail I will provide. Let's say name. Let's say name. Anything we will provide here. Let's say Aman, Rohan. Let's say Sohan. Okay. Next detail I will provide department ID. Let's say department ID. Department ID. Let's say 20, 10, 20, 30. Okay. So I have created a data frame, employees. Now I will create a new data frame, departments, and I will show you how we can merge the data set using pandas like SQL. Okay, like how we can merge like SQL in pandas. Okay, I will use data frame. I will end this by a parenthesis. Now let's say I will give department ID because it should be common in both department ID. That is how I'm going to merge it. Okay. Depth ID. Okay. I will give the same values 10, comma 20, comma 30 so that I can merge the data set. Merge two tables into one. For that we need a common column, that is our department ID. Let's say department name, and I will provide, let's say, IT, HR, and let's say sales. Okay, I have created a two data frames here. I will fix it the center. If you will see your employees, it is looking like this. If you will see your departments, it is looking like this. Now we are going to merge this data set, these two tables into one. Okay. So first we will join these two tables into one. First is our left join. How we can do left join? Left join. I will give a markdown here. Left join. So I will use pd.merge. Pd.merge. What I want to merge? Employees, departments, departments, and then on which basis I want to merge these two tables. Remember, I have a common column here, department ID. So I will use on is equal to on basically I have written home on department ID. Sorry, not department name, it is department ID. On department ID, and remember I am doing a left join, so I will give how to left left how I am doing left join I am doing. Okay. So I did a mistake here. Here I will do depth type. Okay. It was not matching. Okay. Now if you will do now. Here you can see it has merged. How it has merged? From left. Okay. So here you can see I have employee ID, name, department ID, and department name. Okay. So now let's see how we can do right join. Simply I will use how as right. Sorry. I will use markdown here. Right join. Simply I will copy this and I will give this right. Now here you can see it is joined by right join. Similarly, I will use outer join. Outer join. I will give the markdown here. Shift to center. Similarly, I will do how as right. Right. Okay. Sorry, not right. This time I will use outer. Now, this is how we can merge the data. This is how we can merge this data. Okay. So that is all about in pandas. Okay. In the next tutorial, we are going to see Matplotlib and Seaborn. Okay. That's all in this video. Thank you. So hello guys, welcome to the channel. So today we are going to discuss complete data visualization using Matplotlib and Seaborn library. Okay. So first understand what is data visualization and why it is important. Okay. So data visualization is the graphical representation of information and data. It uses visual elements like charts, graphs, maps, and dashboards to help humans understand patterns, trends, outliers, and insights in data easily. Okay, so suppose if you have a data set, okay, there are multiple columns in your data set. You will not gonna recognize every pattern and trend by only seeing the data. Okay, so you will need to basically plot some graphs to analyze the trends and patterns. Okay, that's why we use data visualization for our data set using our data set. Okay, so there are some key elements like data, the raw facts and figures. Okay, then visual elements, charts, graphs, maps, colors, label, etc. Purpose to communicate information clearly. Okay, audience, end users, your maybe customers, or you can say your decision makers. Okay, so why it is important? First is your easier understanding. Okay, visuals are processed 60,000 faster by the brain than text, right? So they make complex data easy to grasp. Okay, identify patterns and trends. I have already discussed. Helps in spotting patterns, trends, correlations, and outliers that are difficult to detect in raw data, right? So better decision making, clear visual insights help business and individuals make data-driven and confident decisions on the basis of the charts, on the basis of dashboards. Okay, save time. So provides a quick summary of large data set. You have millions of records in your data set. It will provide a quick summary of your data set. Okay, saving time in analysis and interpretation. Okay, improves communication. So visualizations communicate insights effectively in both technical and non-technical audiences. Okay, most most important, no, non-technical audiences, right? Because they will not understand your code. You are using Pandas, NumPy, Matplotlib, and Seaborn, right? They will understand by your graphs, dashboards. Okay, enhances impact. So create visuals make your message memorable and have a stronger impact. So now let's understand your first library, that is the Matplotlib. Okay, so Matplotlib is a powerful and widely used Python library for creating static, interactive, and animated visualizations in Python. So, Matplotlib is a foundational data visualization library in Python that provides a flexible interface for creating a wide range of plots, such as line plots, bar charts, scatter plots, histograms, pie charts, and many more. Okay, so what are the key features of Matplotlib? So it provides you high quality 2D plots and a variety of plot types. Okay, because it is customizable. Okay, colors, labels, legends, grid, styles. You can customize these things in Matplotlib. Okay, publication quality figures works well with NumPy and Pandas. We have already discussed NumPy and Pandas. Okay, so it is a cross-platform and open source. Okay, what is the basic workflow of Matplotlib? You will import Matplotlib, you will prepare data, and you will create it. Then you will create a plot. You can customize plot according to your need, and then display or save plot. Okay. So these are some basic syntax. You have two columns, like two kind of data, and you can make graphs on the basis of your data set. Okay. Now, let's understand bar charts and pie charts. Okay, so bar charts are used to compare and display categorical data using rectangular bars with lengths proportional to the values. Okay, so there are two types. Key points of bar charts are used to compare values across different categories, can be plotted vertically or horizontally, best for discrete data with a few categories, and easy to read and intercept. You can see there are two types of bar charts. First one is your vertical bar chart, and second one is your horizontal bar chart. Okay, so we will see how we can draw bar charts and pie charts practically, but first understand, basically take an idea about these charts. Okay, you guys already have studied in your maths about these charts and all, but I'm giving you a quick recap. Okay, so second one is your pie charts. Pie charts are used to show parts of a whole. Each slice represents a category's proportion of the total. You can see there is one category 10%, there is second category 15%, 20%, 25%. Okay, these are different categories. These are different categories. Okay, classified in this category A, category B, category C, right? So, what are the key points of pie charts? It shows percentage or proportion of each category. All slices together represent 100%, the whole. Okay, best when categories are few. Okay, ideally less than 6, 7. It will basically it will not look good when you will have multiple categories, like 20 to 25 categories when you will have. Okay, so it will be good only when you will have less categories. Okay, so it if you will have 20 to 25 categories, it will look like very crowdy. Okay, so easy to understand and visually appealing. Okay, now let's understand how we can plot bar charts and pie charts practically. Okay, so let's begin with the bar charts and pie charts practically. Okay, we are going to see how we can plot bar chart and pie chart. So I will use this data set. Okay, I will use this dataset. This is a supermart sales dataset in which I have order ID, customer, categories, subcategories, city. and discount profits like this state. Okay, like these things I have. So we are going to see how we can plot bar charts using this data set. Okay, so first I will import some required libraries like Pandas, LPD because I need to load my data set, and then import Matplotlib dot pyplot as PLT. Okay, if you don't have Matplotlib, you can use pip to install Matplotlib library. Okay, so I will load my data set. Data is equal to pd.read slash csv, and then I will give the path of my file. This is my file. Copy path, paste. Let's check my data is loaded or not. Data.head. Let's check its first three rows. Yeah, my data set is loaded. Okay. Now, in this data set, you can see the basically category column. Okay, it is representing different product categories. Okay, different product category. So while the sales column is telling you the sales amount. Okay, so let's compare the total sales total sales generated by each category. So what I will do first, I'll make a new variable. Let's say category sales is equal to, what I will do, I will use group by. I've already discussed when I was discussing pandas, what group by do. I will use group by and I will use my category, and then from which I am grouping sales, right? Sales. Okay. Now what I need to uh, check the total sales for each category, right? So I will do sum. Okay, sum. Okay. Now, let's plot bar chart first. Okay, I will give a markdown here. Bar chart. I will use markdown here. Shift plus enter. Okay, bar chart. Now we will plot a bar chart using this category sales, in which I have calculated total sales by each category. Okay. Now I will use plt.figure first. What plt.figure do? It will help us to basically resize, basically in sizing, basically in customizing the size of my plot, my charts. Okay, so I will use big size is equal to, let's say, 8 comma 5. Okay, you can customize this. Okay, from 8 to 5, or you can check by putting any number. Okay, it is just for resizing your chart size. Okay, now you want to plot bar chart, right? So you have imported Matplotlib library alias PLT. So I will use PLT dot. I want to plot bar chart. So I will use PLT dot bar. I will use my category cells which I have created. Category cells dot index. It will be your axis. Okay, it will be your axis, and then category sales dot values. It will be your y axis. Okay, dot values. Okay, and then something you can see, you can give color of bars. Your color of bars. Let's say I will give sky blue. Okay, I want my bars as sky blue color. and you want to give some borders for your bars. Okay, so you will give edge color edge color is equal to, let's say I want to give black. Okay, uh black. Now let's say I want to give some thickness of my border also. So how you can give thickness of your bars border? You will use line width. Line width is equal to, let's say I'm giving 2, comma, label. Label we will use for legend. It will show, let's say I'm using total sales. Total sales. Okay. So it will be shown in your legend. Okay. I will explain what is legend and all. Okay. Now, next thing is your plt.title. Plt.title will be your title of your graph. Okay. Plt.title will be your graph. Okay. So let's say I'm giving something total sales by category. Category. Okay. And you can give font size also. Okay. Suppose I am giving font size as, let's say, 16. Okay. And suppose I am giving X level something. What will be shown in you? A label for X axis. Okay. Plt dot X label. Let's say I'm giving. It will be my category because I'm taking category sales dot index. Okay. So it will be my category. Okay. Again, you can give some font size. Font size is equal to 12. Let's say. Okay, similarly, you can give plt dot y label. It will be label your y axis. Let's say I'm giving sales sales. Okay, sales. Now next thing I will add some grid. Okay, grid. I will explain once chart will be plotted. I will explain once again everything. Okay, axis is equal to, let's say, y. Okay, and you can style your grid lines as, let's say, line style as something like I want this kind of styles, let's say. Okay, and I will give alpha is equal to 0.5. Okay, now I will give plt dot legend so that it can show what are in the graphs, and now simply I will put plt dot show plt dot show. It will line style, it will be line style. Okay, now here you can see your bar chart. Now I need to give y label, y label. Okay. Now here you can see it is your sales. It is your on the x-axis your category. There are your categories, and here you can see a scale for your sales. Okay. Now you can see we have plotted a bar graph. Okay. So on the x-axis, we have taken categories, and on the y-axis, I have taken the values. Okay. Color is equal to sky blue. You can see your colors of your bars. Okay. Sky blue, that is. Okay. Edge color means border. I have taken black and with line width 2. Okay. So here you can see your border. Okay. With black color. Okay. Now here you can see we have taken plt dot titled total sales by category. Okay. And on X level, I have category. On Y level, I have sales. Okay. Now you can see grid. Grid means I have taken X is equal to Y. So you can see here, here it here it is showing grid lines in this form. In this form, line style is equal to this, and in this form, you can see I have grid. Okay, horizontally. X is equal to Y I have given. It is plotting. Uh, it is giving me grids in horizontal. If you will plot X is equal to X, let's X is equal to X, then you can see it will give me grid lines in vertical direction. I am giving Y here, so it will give me horizontal direction. Okay, all the grids. Okay, plt dot legend. This total cells you can see. This is because of plt dot legend. Okay, so this is how you can plot a bar chart to compare. We are comparing. Okay, total sales we can see here. Snacks has the highest sales, I think, or meat and something like that. I have different kind of sales. Like we can increase our font. We can increase our plot. Yeah, you can now you can clearly see your all the all the categories. Okay. Now, I think eggs, meat, and peas has the highest sales with compared to snacks. Okay. So this is how we can check these things using bar chart. Bar chart. We can compare categories or something. Okay. Using bar chart. Okay. So this is how we can use bar chart. Now let's understand pie chart. Okay. I'm giving pie chart as marked down here. Pie chart. So, so in pie chart, we will basically visualize the percentage contribution of each product category, each product category. Okay. So to the total sales. Similarly, okay. Now I have already created category sales in which I have taken sum of each category sales. Okay. Total sales of each category. Okay. So I will use this again. So let's plot first a basic pie chart. Okay. I will use plt.figure. Plt.figure. I'm giving some figure size. Fig size is equal to, let's say, 7,7. Okay. Now, now you want to plot pie chart, right? So you will use plt.pie, just pie. And one more thing in bar chart, if you want to, this is your vertical bar chart, right? This is your vertical bar chart. If you want to plot horizontal bar chart, just use bar H, bar H. Now you can see it has plotted your horizontal bar chart. Okay, so this is how you can plot vertical bar chart. Default will be your vertical bar chart. If you want to plot horizontal bar chart, then you can use bar H. Okay. Now let's continue with our pie chart and plt.py. Again, we will use category sales values and index. Okay. I will use category sales values and index dot values and dot index. Okay. Now, I will give some label. Label is equal to, I will use category sales index. Okay. Sorry. We will not use index here. In here you will use index. Okay. In your label. Okay, in your label. Now, now let's give some title for your pie chart. Let's say sales distribution, sales distribution by each category, category. Okay, each category, and then plt dot show. Okay, not label here, labels. Now here you can see it has plotted a pie chart. Okay, pie chart. Here you can see have eggs, meat and fish, sport, grains, bakery, snacks. Okay, like it has plotted. We have plotted a basic pie chart. Okay, now we can customize some things in our pie chart. Okay, it is looking good because we have only 7 categories. It will it will look very crowdy when you will have 20 25 categories. Okay. So let's say you want to show some percentage for each category. Okay. So what you can do, you can use auto percentage is equal to, you can use something like percentage 1.1. Let's say you want to keep only one decimal value, then you can use 1.1 f, then use percentage. Okay. Now if you will run this, now here you can see it has provided you percentage. What are the percentages? Okay, 15.2 eggs, meat and fish has the highest percentage. You can see it has, it is sold most of the time. Okay. So here, like this is how you can use auto PCT, means auto percentage, like this to show percentage for your each slice. Okay, each slice. Now let's say you want to change some colors. You want to customize some colors according to yourself. Okay. So what you can do here, you can make a list of colors. Make a list of colors. Let's say you will give some colors like sky blue, sky blue, and let's say orange, and let's say light green, let's say pink, and let's say violet color. Okay, now you have a list of colors. Now you want these colors, your customized colors. Okay, so simply you can use colors. Color is equal to, color is equal to your list. What is your list? What is your list name? Colors. You can simply provide colors. Okay. Yeah. Here you can see it has customized your. It is replaced by your customized colors. Okay. So this is how you can use your own colors also. Okay. So now next thing is, let's say, exploding slice. So suppose you want to move your first slide, that let's say this is your first slide, and you want to move first slice slightly outside. It will not be here. It will be something like, it will explode something here. Okay. If I will show you, uh, let's say I will create explode is equal to, let's say 0.1 comma, let's say 0 comma 0 comma 0 comma 0. Okay. Now if I will use explode, is equal to explode, and I will give shadow is equal to, let's say, true. Now, if okay, so I have seven categories, right? Zero, one, two, three, one, one, two, three, four, five. Okay. Now we will use two more. Now here you can see it has considered your first slice. Now you can see you have given shadow is equal to true. Now you can see here shadow as well, and you can see it has exploded a little bit. It has moved a little bit. Okay, it has moved slightly. Okay, this is your first slide. You can use your you can explode your second slide also. Something like this. You can see like this. It is exploded your second slice also. So generally we explode only one slice. That is our first slice. Now here you can see it is looking better now, right? Now suppose you want to rotate your pie chart. Okay, rotate your pie chart. So simply what I will do, I will use a start angle. So start angle is equal to 90. So it will rotate the graph by 90 degree. Okay. Yeah, you can see it has rotated the graph by 90 degree. Okay. So this is how we can plot bar charts and pie charts. Okay. So this is how we can use bar charts and pie charts. Okay. Now next is our stack plots and histograms. Okay. So let's understand first about stack plots. So stack plots, also called area stack plots, are used to show the cumulative total of multiple categories. Remember this, multiple categories over a continuous variable, usually time. Okay. So its key points are visualize how multiple categories contribute to a total over time. So the areas are stacked on the top of each other. Okay. The top edge represent the cumulative total, and the total useful for showing trends and changes in composition. Okay. So this is a basic example of the stack plot. Okay. And you can see on the basis of time we are comparing our sales of product C, B, and A. Like this. Okay. So this is how we can use a stack plot. Okay. So to basically compare the total of multiple categories over a period of time. Okay. And second thing is our second plot is our histogram. So what are histograms? Histograms are used to show the distribution of a continuous numerical variable. Remember this. This is the difference between histograms and bar charts. Bar charts for categorical data, and this is for numerical data, numerical variable, by dividing data into bins. Bins means intervals. Okay. So the key points of histograms are shows the frequency count of data points within range bins. Bars are adjacent, no gaps between them. Okay, here you can see there is no difference. Like bar chart, there is no difference between them. Helps us to understand the distribution shape and useful for identifying patterns like skewness, spread, and outliers. Okay, so let's see how we can plot stack plots and histograms practically. Okay, let's see. Now we are going to plot stack plot using same data set. So what I will do, I will plot a stack plot to basically compare the total sales, profit, and total discount amount. Okay, across different regions. Okay, across different regions. Okay, so let's see how we can plot stack plot. Okay, now I will give a markdown stack plot. Now what I will do, I will introduce a new column, the total discount amount, okay, in our data set. Okay. So what I will need to do, I will need to multiply total sales with our total discount to calculate the total discount amount. Okay. So what I will do, I will introduce a new column. Let's say discount amount. Okay. Discount amount and is equal to data. I will take uh, sales and discount. Okay. Sales and discount. So I will use sales into discount. Okay. Discount. Okay. Discount. Okay. Okay. I will use the same column. Okay. So here I forgot to introduce our. Okay. So I have introduced new column discount amount. Okay. Now we will group the data by region. Okay. So I will create a new variable. Let's say region data. Region data is equal to, and I will use dot group by. What I need to group? I need to group region, right? I need to group region, and what are the different columns through which I am grouping. I will use double square braces. What are the different columns? My columns are sales, and my second column is my profit, uh, profit. Okay, profit, and third one is your discount amount. Okay, I am grouping this, and I will use dot sum. Okay, if you will see your not this is code, and I will use reason data. Let's check our reason data. Now here you can see this is our reason data. There are total regions. These are my regions: sales, profit, and total discount amount. These are total discount amount. Okay. Now, now let's create lists for x-axis and y-axis. Okay. So for x-axis, what I will use, I will use regions. Okay, regions will be my region data dot index. Okay, this will be my x-axis. Okay, now let's create for y-axis. In y-axis, there will be my three things: sales, sales, region data, sales. Okay. Similarly, two more things will be in my y-axis. That will be my second one will be my profit. Let's create a profit variable, and I will use here profit, profit, and third one will be my discount, discount. Okay, and here I will use discount amount. Okay, I will use discount amount. Okay, now my data is prepared for plotting my stat plot. So now let's first create a basic stat plot without any customization. Okay. So PLT, I will use PLT.figure for my for giving some figure size. Let's say fig size is equal to, let's say I'm giving 10 comma 6. Okay. Now I want to plot stack plot, right? So I will use plt.stack. plt.stack. Now I will use for my x-axis regions. Regions will be my x-axis regions, and what are the things will be in my y-axis? Sales, profit, and discount. Discount. Okay, discount. So regions will be my x-axis. Sales, profit, and discount will be on my y-axis. Okay. Okay. Now let's give some title. Plt.title. Let's say region wise, region wise contribution, contribution. Okay. Now, I will give some X label, plt.x label. Let's say I'm giving on X axis will be my region. Region will be in my will be on my X axis. So I'm giving X label as region. And similarly for Y label, there will be my sales, profit, and discount. So I will give something like amount. Okay. Now I will write plt.show. Sorry, not stack. You will use stack plot. Now here you can see it has plotted my stack plot. Now let's customize few things. Okay. Let's say you can give labels. Okay. So there are three labels here. So you can use your labels. Okay. So like you can give labels. Labels is equal to, you can give sales, sales, profit, profit. Okay, and then you can give discount. Okay, discount. Okay, you can use your custom colors as well. Colors is equal to, let's say I'm giving sky blue, sky blue. Next, let's say I'm giving orange, and next I'm giving, let's say, red. Okay, now if you will run this, now here you can see I have given labels. I have given labels, and for that you need to use plt.legend. Now here you can see it has provided me labels. Blue for sales, orange for profit, red for discount. Okay, so this is how you can use labels, colors, your customized colors for plotting stack plot. And let me decrease the height. Okay, and decrease the height of this graph. Next, let's say you want to give transparency. You want to give some transparency, so you can give uh, one more thing. Here you can see location of your legend. You can customize your location. Location is equal to, let's say uh, you want to put this here. If this is upper left, so you can use upper left. Okay, upper left. Now here you can see this is how you can customize your plt.legend. Okay. Now here you can see we have used labels, colors. Let's say you want to give some transparency, so you can use alpha for that, for transparency. Let's say I'm giving something 0.8. Okay, here you can see it has increased my transparency a little bit by giving alpha is equal to 0.8. Now let's say you can use plt.grid as well. Okay, you can give grid as well, plt.grid, and something like you can give some line style how you want your grid lines. Let's say I want this style dash dash, and let's say I'm giving alpha is equal to for transparency. I'm giving alpha is equal to 0.4. Now you can see it has provided me grid as well. Okay, so this is how we can plot a stack plot. Okay, so this is how we can do customization as well for our stack plot. Okay, so this is how we can plot our stack plot. Okay, now next is our next we will plot our histogram. Histogram. Okay, so I will give a markdown here. Histogram. I will give markdown here. Histogram. Okay, now for histogram we will use this sales column to understand how sales values are distributed. Okay, how sales value are distributed. Okay, so let's create first a basic plot. Plt dot figure. Let's say I'm giving some figure size. Fig size is equal to, let's say I'm giving 8 comma 5, and I want to plot histogram, right? So I will use plt.hist. Okay, only plt.hist. So what column I want to understand. I want to understand about sales column. So I will use sales here, and I will give some title for my graph, plt.title, and I'm giving something like distribution of sales, distribution of sales, and I'm giving plt.x label, plt.x label. Let's say I'm giving sales. Okay, sales. Sorry, not zero here. And I will give some y label as well. I'm giving, let's say, frequency, frequency. And now I will give plt.show. Plt.show means plot my graph. So this is how you can see it has plotted my histogram. Now you can customize your uh, histogram. Let's say I'm giving some beans here. Beans means divide my data into that particular times of intervals. Let's say I'm giving beans is equal to 10. So it will divide my data into 10 intervals. Okay. Now you can give color and edge color as well. You can customize your color and edge color as well. Let's say I'm giving color. Color is equal to, let's say I'm giving sky blue, sky blue. And then let's say I'm giving edge color, means my border edge color is equal to, let's say I'm giving black. Now here you can see it has provided me the border and my customized color. So this is how it is looking. Now it is looking better. Okay. My histogram is looking better now. And for transparency, you can use alpha. Alpha you can use for transparency. Let's say you will use 0.7, and I am giving I've given 0.7 here. Okay. So and you can use plt.grid as well. Plt.grid, plt.grid, and again I'm giving something is line style as let's say dash dash, and then I'm using alpha. Alpha is equal to 0.5. Okay. If you don't want to, if you want to use your sorry, custom grid, you don't need to give line style here. Okay. Suppose I am not giving any line style here. Here you can see this is how it has provided me. Alpha is equal to 0. Alpha is basically for transparency. Okay. So this is the custom grid lines. Okay. This is our custom grid lines. If you will add here line style is equal to dash dash, then it will provide you the custom grid lines. Okay. Dash dash. Okay. So this is how we can use, we can plot our histograms and stack plot as well. Okay. Now next is our scatter plots and subplots. Okay. So first understand what are scatter plots. So scatter plots are used to visualize the relationship between two numerical values variables. Okay. Each point represents an observation. Okay. Like this. Suppose you have weight and you have height. So this is giving a relationship between your height and weight. Okay. So this is for what we use scatter plots. Okay, so there are some key points of scatter plots. It shows the relationship or correlation between two variables, helps identify patterns, trends, clusters, and outliers, and points are plotted on a 2D plane using XY coordinates. Okay, so does not connect points, emphasize individual observations. Okay, so It it is useful for regression analysis and exploratory data analysis. Okay, so uh, when we will use scatter plots to explore relationship between two numerical values like this two to detect correlation, positive, negative, or no correlation, to identify clusters or outliers in data, and in machine learning for feature analysis. Okay, so So it is best for bivariate data, two variables, correlation analysis, trend identification, exploratory data analysis, EDA, and scientific and statistical studies. Okay, so this is about scatter plots. Now, what are subplots? So subplots allow you to plot multiple charts in a single figure. Okay, single figure, multiple charts like line plot, bar chart, histogram, pie charts. Okay, so key points are it helps to compare multiple plots or aspects of data together, saves space and improves clarity in presentations. Okay. Each subplot is independent with its own title and labels, arranged in rows and columns, grid layout, and useful for dashboard like visualizations. Okay. When we will use this subplot to compare multiple plots side by side when visualizing different aspects of the data. Okay. To create dashboards or summary reports and to save space in presentations or reports. Okay. So it is best for comparing multiple data sets, dashboards visualizations, report analysis, presentations, and exploratory data summaries. Okay. So this is an example of your subplot. Okay. Let's understand how we can plot scatter plots and subplots practically. Okay. I will plot a scatter plot. Okay. First, I will give a markdown here, scatter plot. Okay. I will give a markdown here. Okay. Now, what I will do, I will compare sales and profit, my sales and profit using scatter plot. Okay. Using scatter plot. So, what I will do, I will plot a graph. I will first give a figure size figure. I will give some fig size is equal to, let's say, 8 comma 5 8 comma 5. Now I have to plot a scatter plot, right? So I will use plt dot scatter. Okay. Now what I need to compare on the x axis, I will take my sales, and on the y axis I will take my profit. Okay, I will take my profit. Okay, and now let's say I am giving my title sales versus profit. Okay, now PLT I will give a X label, PLT dot X label. I will give sales, and on the Y label I will give I will give profit. Okay, because on the Y axis I have profit, and I will give PLT dot show. Now here you can see this is how it has plotted my graph. Okay, now we can do some customization. Suppose I am giving my custom color here. Let's say I am giving royal blue. Royal blue. Okay, royal blue. And next, let's say I am giving size of every point, every scatter 100 as 100. Okay, 100 is equal to 100. Now, uh, let's say I can give marker also. Marker. Let's say I'm giving marker as triangle. Okay, triangle. You can give O, S, star, D plus. These are some common markers. You can use those also. And alpha I'm giving for transparency is 0.6. And let's say I'm giving edge color, edge color, edge color as black. I'm giving black as my edge color. Now let's see. So this is how it has plotted because there are so many pointers we have. There are so many scatters. So it is looking like quite crowdy here. So, but this is how you can plot a scatter plot. You can use grid as well. PLT dot grid. Okay, you can give alpha as 0.5, let's say. So this is how you can plot a scatter plot. Okay, this is how you can plot a scatter plot. Next is let's say how you can plot a subplot. Subplot is nothing but your combination of your collection of various graphs. Okay, let's say I'm giving a markdown here subplots. Okay, subplots. Now, what I will give first graph, let's say I will plot a histogram. Let's say I will plot a histogram. Okay, so I will first give here plt dot subplot. I will give 1 comma 2 comma 1. What is the meaning of 1 comma 2 comma 1? 1 is your one row, 2 means you will have two columns, and 1 means your first graph. First graph what will you will plot. So I'm plotting a hist plot, plt.hist. Now I will use data, let's say sales. I'm comparing my sales bins. I'm giving 10. Let's say color I am giving let's say sky blue. Edge edge color edge color. Let's say I'm taking black, and I am giving plt dot title. I am giving sales distribution. Okay, this is my first graph. But subplot is a combination of your graphs. You can plot multiple graphs into a single plane. Okay, so now what I will do, I will plot a second plot, subplot, 1 comma 2 comma 2. Now 2 will be your second graph. Okay, what you will gonna plot in second plot. Let's say I'm again plotting a scatter plot. First time in the first graph I am plotting a plot, and second time I am giving a scatter plot. Okay. Same thing. Let's say I will give this only. Will be, and let's say I am giving a title plt dot title sales versus profit. Sales versus profit. Profit. Okay. This time I'm taking only two graphs. You can plot multiple graphs, four graphs, five graphs, six graphs. You can plot that. Okay. But for now, I'm only plotting two graphs to show you that in the subplot we will have multiple graphs together, not only single like this. This I have a single graph. I have a single graph. I have a single graph. In this, we can plot up multiple graphs into a single plane. Okay, and plt dot I will use plt dot tight layout. What is this tight layout means? Tight layout. What it will do? Tight layout will automatically adjust your spacing. Okay, that's why I've used tight layout. Okay, now I will do plt dot show. Now let's say you want to the sales versus profit is for this is the heading for this, and sales distribution for this plot, but you want to give a main title, okay, for both of these two graphs. How we can do? We will just write plt dot subtitle subtitle, and I will say, let's say, sales distribution sales distribution, and let's say font size will be my 18. Okay, let's run this. Now here you can see uh, this is how it has given me two plots. Okay, you can have multiple plots, three, four, five, six. Okay, I have not given any here. I have not given any plt dot fig size. You can adjust your figure size using plt dot figure and fig size, like this one, like this one. Okay, you can adjust this. Let's say I'm taking this. Okay, and I will give for first one, and then again for the second one. Here you can see it has given me this. Okay, now I'm removing this. Okay, to make it. Okay, so this is how you can plot subplots. Okay, now I am using only two plots here. You can use multiple plots. Okay, multiple plots. So this is how we can use subplots. We can plot subplots and scatter plot. Okay. Now let's understand about Seaborn. Okay. So Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics with less code, with less amount of code. Okay. So what is Seaborn? So Seaborn is a data visualization library built on the top of Matplotlib, and it simplifies the creation of complex and attractive statistical plots. It works closely with Pandas data frame. Pandas data frame. We will see when we will learn machine learning. Okay. So it is designed for exploring and understanding data. Okay. Now next thing, what are the key features of Seaborn? Built-in themes and color palettes for better looking plots. High level interface for drawing statistical graphics. Supports a wide range of plot types. Okay. Automatic handling of pandas data frames. Okay. Excellent for data exploration and analysis. Okay. Now third one. Why should we use Seaborn? So Matplotlib is a powerful but can be complex for statistical plots. Statistical plots. So Seaborn makes it easy to create informative and attractive plots. Okay, so it provides sensible default style. It reduces the amount of code and Great for exploratory data analysis, EDA. Now, how Seaborn actually works. So Seaborn functions operate on entire datasets and internally use Matplotlib. It will use internally Matplotlib. Okay. So it understands the structure of the data first and then performs statistical aggregation. Okay. It provides informative visual cues, color, size, positions by default. Okay. You will not able, you don't need to customize this. Okay. It will use this thing by default. So you can customize plots further using Matplotlib if needed. Okay. So you will need to use Matplotlib for further customization if you need any customization. Okay. So fifth advantage of Seaborn. So it built attractive default. It has inbuilt attractive default style and color palettes. High level functions with simple syntax, designed for statistical relationships, integrates well with pandas, and saves time and reduces code. Okay. Now, when should we use Seaborn? First is explore in exploratory data analysis. Understand patterns, trends, and relationships with less amount of code. Remember this. So it is statistical visualize. So distributions, correlations, and comparisons. Okay, with less amount of code again. Quick insights. Get meaningful visual insights with less amount of again. Okay. So publication. Next is publication. Quality graphics, beautiful plots for reports and presentations. Okay. So now let's see how we can plot some basic some graphs using Seaborn. Let's see how we can do it practically. Okay. Let's plot some graphs using Seaborn. We will use this dataset only for plotting graphs of for Seaborn also. So first I will plot a line graph, line plot using Seaborn. I'm giving a markdown here. Line plot using Seaborn. Okay. So what I will do, I will plot a graph using index of the data, index of the data with sales by comparing these two. Okay. So how we can plot a line plot using Seaborn? First, I will use plt.figure for giving some figure size. Fig size is equal to, I will give 8 comma 5, let's say, and I will plot a line plot. So I will, sorry, first what I need to do here, I have not imported Seaborn, right? So I will import Seaborn as SNS. Okay, I have imported Seaborn as SNS. Okay, now what I will do, I will use plt.figure. I will give some figure size, let's say 8 comma 5, 8 comma 5. I will use SNS dot line plot because I want to plot line plot. So I will use line plot. I will give x I will give data dot index for x axis. Okay, whatever the index of my data set. Okay, data set index. Okay, and with and on the y I will give sales. Okay, for y I will give sales. Y is equal to data. I will go for my sales. I will give my sales. Okay. Now what I will do, I will give a title here for my graph, plt.title. Let's say sales trend, sales trend. Okay. Now I will give some X label and Y label also. X label I am giving, let's say, order number, order number. And for the Y label, I will give something like sales, sales. Okay. Now I will plot my graph, plt.show. Now here you can see it has imported line line plot. Okay, so it is looking very noisy because there are so many data points, so many indexes, and so many sales data points are there. Okay, not only 10, 25 categories, there are multiple categories. When you will have 25, 30 categories, it will show clearly. It will be shown clearly. Okay, so but this is how we can plot a line plot. Okay, next is our scatter plot. Scatter plot using Seaborn. Okay, scatter plot using Seaborn. This will we will plot similarly. I will use only those kind that data set which I have taken for Matplotlib here. Okay, I will use that data only. So first, let's say I'm copying this plt.figure. Okay, I will copy this. Now I have to plot a scatter plot, right? So I will write this sns dot scatter plot, scatter plot, and for data, I'm giving data. Data is my data because in the data variable, I have taken the data set. And for the x-axis, I will take sales. And for the y, I will take profit. Okay, profit. Again, I'm plotting sales versus profit. And this time, I will give a hue parameter. Let's say region. Okay, this will be my hue parameter. And size, I'm giving for every scatter 100. Okay. Now, similarly, I will copy this y title x label y label also. I will change this. I will let's say give sales versus profit again, and let's say I will give sales here, sales, sales, and here I will give profit. Okay, so this is how it has given me. It has plotted the data plotted a scatter plot for my sales versus parameter. Okay, hue parameter is my region, north, south, west, central, east. Okay, so this is how we can use hue parameter. Okay, so by taking an another column. Okay, rather than x and y. Okay, now let's say I will plot a bar plot using Seaborn. Okay, bar plot using Seaborn. I will give a markdown here. Now I will simply copy my figure size. Let's say this time I'm giving 10, 5, and let's say I have to plot bar plot, right? So I will use bar plot, sns dot bar plot, and let's say for data I'm giving data because in data variable I have saved the data. Now for let's say I'm taking category versus sales now. Category, category, this is my category, and these are my sales. So I will take category versus sales for bar plot, category, and on the y-axis I will take sales, right? Sales, and again I will copy my title, X label, Y label, and all these things. Title this time I will give suppose average sales by. category by category. Okay, and X label I will take those category, and on Y label, I will take sales. Okay, I will use xticks, let's say 20.xticks. I will give some rotation is equal to, let's say, 45. Okay, now let's run this. Now here you can see it has plotted my bar chart, bar plot. Okay, this is how we can use bar plot. Okay, using P1. This is the this is because x you can see here rotation is 45 here. This is how it is showing my categories here. Okay, so this is how we can plot bar plot using Seaborn. Okay, next let's say I will plot a box plot using Seaborn. Box plot using Seaborn. I will give a markdown here. Now, again, I will copy this. Let's say I'm giving 10 again. Uh, Now I have to plot a box plot, right? So I will use SNS dot box plot, and I will give data as my data because in my data variable I have saved my data. And then let's say this time I am taking region in my x-axis, on my x-axis, region, region. Okay. Now let's say y is equal to is time take I will take, let's say, sales region, sales per region. Okay, so I will copy this again, pt.title and all this. Okay, now on X label I will have region. On Y label there will be my sales only. X sticks I don't want here, and uh, I need to change the title of my graph. Okay, this time I will give sales distribution, sales distribution by region. Okay, region. Now let's run this. Now here you can see it has plotted bar plot, sorry, box plot. Okay, this is how we can use we can plot box plot. Okay, now next is let's say I will plot a heat map for uh, knowing my for to know my correlation between these sales, profit, and discount columns. To know the sales, discount, profits correlation, I will plot a heat map. Okay, plot a heat map. Let's say I will make a new variable here. Numeric data is equal to. I will take all my numeric columns in this. Okay, what are my numeric columns? My numeric columns are sales, uh, profit, profit, and third one is my discount. Okay, discount. Okay, now I will make a new variable correlation core CORR, and I will take the correlation into my core CORR. Okay, so okay, I have taken numeric data. In numeric data, I have sales, profit, and discount. And in correlation, CORR variable, I am storing the correlation between these three columns. Okay. So now if I will plot lt dot figure fixed size, fixed size is equal to, let's say, 6 comma 5. Let's say 6 comma 5. Okay. Now I want to plot heat map. Okay. Suppose I will give a mark on here, heat map using Seaborn. Using Seaborn. Okay. Now SNS dot, I will use heat map. Heat map. Now what I will give? I will give for CORR and not is equal to true to make it true. Okay. And then I will use CMap. CMap for color theme. Okay. CMap I will, let's say, use cool warm. Cool cool warm. Okay. And I will take, let's say, line width. And not is equal to true means basically to know to see the values. Okay. I will plot the graph and I will explain. And I will, let's say, give a title, correlation heat map. Correlation heat map. Okay. And I will give plt dot show. Now here you can see your plt dot. Now this you can see here, whatever the value will be close to one will be the great great related to each other. Okay, it will be correlated to each other. Okay, the values here which will be close to one. Okay, that will be your correlated. That will be your mostly related data with each other. Okay, with sales, profit, and discount. So this is how we can plot a heat map to know the correlation between our columns. Okay, so that's all in this video. We have plotted many graphs using Matplotlib and Seaborn as well. We have plotted many graphs, and this is how we can use Matplotlib and Seaborn for data visualization. Okay, so that's all in this video. Thank you.